Next problem on the list is number 8. Did I give you a page number on those? Yeah, page 184. Okay, good. Number 8. Well, how does this work? The same deal. I have y equaling the complementary plus the particular. Particular is linear. That's a fun problem. But the complementary, I need to let y equal e to the rt. And that's going to give e to the rt into r to the 4th plus 2r squared plus 1 equals 0. E to the rt cannot equal 0. It has to be, and this factor into r squared plus 1 squared equals 0. So r equal plus or minus I, and that is multiplicity 2. That means cosine of t, sine of t. Okay, I left that part. Sine of t, t cosine of t, and t sine of t will yield the fundamental set, and I already know that y equals c sub 1 the cosine of t plus c sub 2 the sine of t plus c sub 3 t the cosine of t plus c sub 4 t the sine of t. That would be my complementary solution. Let's go for the particular. The particular solution must be at plus b, right? And if I take a derivative, that is a, no need to modify it. Double prime is 0 and the rest are 0. So if I go back, it seems only y will work. That's 3t plus 4. So actually, I do get a to equal 3 and b to equal 4. There is my general solution, but they gave me initial conditions. Let me see if I could find those. So if I close this down and say y of 0. Y of 0 is c sub 1. That's a 0, that's a 0, that's a 0, that's a 0 plus 4. Oh, how nice. That equals 0. I got c sub 1 to equal negative 4. Very good. Y prime. What is the derivative of this? So different color for each of those. Y prime would be negative c sub 1 sine of t plus c sub 2 the cosine of t plus c sub 3 cosine of t minus c sub 3t the sine of t plus c sub 4 sine of t plus c sub 4t cosine of t plus 3. And if I take y prime of 0, that's a 0, I'll get c2 plus c sub 3, that's a 0, plus c sub 4, nope, that's a 0. Sine of 0 is 0. That's a 0 plus 3, and that equal a 0. So I got this equation. Since c sub 1 is not there, that doesn't help much. Okay, I'm going to take another derivative. Y double prime. That's going to be negative c sub 1, the cosine of t, minus c sub 2, the sine of t, minus c sub 3, the sine of t. Did I do that right? Yeah. Minus c sub 3 sine of t, minus c sub 3t, the cosine of t, plus c sub 4 cosine of t, plus c sub 4 the cosine of t minus c sub 4t the sine of t, and derivative of 3 is 0. And if I take y double prime and throw a 0 in there, I'll get a negative c1, that's a 0, that's a 0, that's a 0, that's a 0, plus c sub 4, plus another c sub 4, and that equals a 1. There's my second, oh, except I know what c1 is. So negative 4 is positive 4, plus 2c sub 4 equal a 1. That means that's a negative 3. C sub 4 is negative 3 halves. I got 2 of those. But that still doesn't help. Well, that gets me, what? C sub 1 I got. C sub 4 I got. I didn't get C sub 2 yet. or c sub 3, I need one more. So let's take one more derivative, and that should do the trick. If I take the third derivative, and I'm taking the derivative of this, that is c sub 1 sine of t minus c sub 2 the cosine of t minus c sub 3 the cosine of t minus c sub 3 the cosine of t. Oh, I should have combined those, that's okay. Minus c sub 3 cosine of t plus c sub 3 t sine of t. Now here, minus c sub 4 sine of t minus c sub 4 sine of t, and the product rule, minus c sub 4 sine of t minus c sub 4 t cosine of t. And if I throw 0 in, I would still get a 1. Y triple prime of 0 would be, that's a 0, negative c sub 2 minus c sub 3, 2 of them, 3 of them. Right? 1, 2, 3 of them. That's a 0, that's a 0, that's a 0, that's a 0, that's a 0. And that equals, according to this, a 1. So here we are. I have a system of equations in which I have c sub 2 plus c sub 3 equal a negative 3. I just copied the red. And the purple, I'll leave it as it is because they add up nicely this way. If I add them, I'll get negative c sub 3 equal negative 2. C sub 3 is negative 1. And if I put a negative 1 there, I'll get c sub 2 minus equal negative 2. So got it. So here, if I go back to the original equation, and the original equation was right there, I will get y to equal c sub 1. I get c sub 1 to be a negative 4. C sub 2, I got it to be a negative 2. C sub 3, I got it to be a negative 1. C sub 4, where's C sub 4? Negative 3 halves. And there it is. That would be the explicit solution. A bit lengthy, kind of fun, I don't know. On my end, it's a lot of fun. I want to do number 10. Number 10 and 12, they don't want us to solve. Be careful when we do the exam, because I'm going to ask you to do this. It says determine a suitable form of the particular. Capital Y of t in this book is actually the particular. You really don't have to worry about the homogeneous. The only reason we need to find the homogeneous to figure out if we need to modify this, nothing else. So, they just want the particular. I find the complementary first by letting y equal e to the rt, because those have constant coefficients and it's linear. I'll get e to the rt. Again, the only reason I'm finding this is because I need to know if I need to modify this or not. That equals 0. E to the rt cannot equal 0. So it has to be r into r squared minus 2r plus 1 equals 0. I have r equaling 0. And this is r minus 1 squared equals 0. So r equal 1 multiplicity 2. Fundamental set, e to the 0 is 1. E to the t and t e to the t. Alright, very good. So, I am going to write the whole solution. They really don't want that, but I'm going to write it. So, this is c1 plus c sub 2 e to the t plus c sub 3 t e to the t. They're not going to have this in the back of the book. They're going to have the particular. Well, let's look at the particular. The first particular solution, y sub p equal at cubed plus bt squared plus ct plus d. The general form of a cubic. But do we notice that this right here is right there? So I need to modify. And if I modify, how do you modify? You multiply by t. And that does it. A t to the fourth plus bt cubed plus ct squared plus dt. That takes care of that piece. Now I look at this piece. I want y to equal a e to the t, but e to the t is there. I modify. How do I modify? I'll multiply this by t. But t e to the t is there. I modify again. So this particular will be a t squared e to the t. And that's all they want. If you really look at the back of the book, they're not going to have the blue portion. They're going to have that pink and greenish part. And that's important. And the same deal with number 12, and that's the last problem I want to do. Again, they just want us to list the particular. The only reason I'm finding they only want this. The only reason I'm finding the complementary, because I need to know if I should modify those. And this is a linear equation with constant coefficients. Let y equal e to the rt. I'm going to get e to the rt into r to the fourth minus r cubed minus r squared plus r equaling 0. I factor an r out. R cubed minus r squared minus r plus 1 equals 0. I take grouping. This was very close to what we did in the beginning. Take r minus 1 out. Oh boy, I love it. There's a key I keep on hitting. I'm going to take r minus 1 out. That will leave me with r squared minus 1. So I have r minus 1 into r plus 1 equals 0. I have r equals 0 and negative 1 multiplicity 2. That means e to the 0, which is 1, e to the negative t, e to the t, and e to the t times t would be the complementary. Now, I'm going to go for the particular. And the particular runs with two components. The particular happen to have a quadratic. The first particular will be at squared plus bt plus c. But I noticed that this is right there. So I modify. How do you modify? You multiply by t. And the particular will be at cubed plus bt squared plus ct. That will do that trick. I notice also that there is a general solution. How do you write that? The particular will be, well, I used a, b, and c, right? It will be dt plus e, like ab plus c, the sine of t, plus dt plus e, the cosine of t. So, the particular solution for this problem is at cubed plus bt squared plus ct plus dt plus e sine of t, plus, you could put cosine first, it doesn't really matter. And of course, you would know how much fun it is to find a, b, c, d, and e. That's a 5 by 5. Your homework is on page 184, number 1 through